Yes.
Perfect. Okay, so yesterday we went till df command, right? So df is used to see the system disk usage, and du will do the same thing but for the user disk page. Okay, and now, so let's say we have a file, right? And we just need to see the, and this is the most used command in Unix or Linux, you know. So let's say we have a file like same file, okay? That's it, test underscore run. So we have file like this file, okay? And we just need to see the top few lines. The first line here is, one second. Okay, so first line here is echo testing this script, blah, 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 right? If I want to see this file using head command, how I will be doing it? I will be doing something like head, and let's say I want to see how many lines. I want to see top 2 lines, right? Head -2, and then test underscore run dot sh. So what it will be doing, one second. But it's not working. Head. Yeah. So see, the best thing about the head command is you do not need to go into file here, right? If you want to see the first 2 lines, if you want to see the first 3 lines, this is used in the industry to see the first header and the first few lines of the data file. Am I making sense? So let's say you have a file with 1 million rows, right? And you just need to see the top 3 rows. What you will be doing, you will be just writing head and -2 and -3 and -3. And let's say if I ask you, let's say one more thing, okay? So let's say if we have a new file called head underscore test.txt, okay? And the file is like this: emp number, emp name. This is header. One second, sorry. So emp underscore number, emp underscore name, okay? So this is header, and the emp number is this, and then let's say this is comma separated file, and emp name is Nilin, and then 2 Ram, 3 Monica, something like this, okay? And the size of this file is, let's say, 1 GB or 100 GB, right? So what if in industry, if you want to validate the structure of this file, what you're going to be doing? You will be writing head -n -2, and then the same head underscore test.txt. So what it will show you that, okay, all the rows, all the top 3 rows are in the same structure. The first row is employee number, the second column is employee name. And let's say if I want to see last 3 rows, okay, I'll cover one more thing in this way, but it won't make much sense. Let me do one thing. So ideally in production, right, whenever you guys go to job, so the top row will most of the cases will be header, but the bottom row or the lowest row will be something like the control row. So it will be like date. Let's say what is the date today? It's 10th June, okay? So 10/06/2021, comma, how many rows are there including header? So it will be 4 rows, right? And something like this. So we will be calling as a trailer row or control row. Okay, so let's say if we want to validate if the number of rows in the file and number of rows, the number in the tail is same. So what you're gonna be doing? You're gonna be doing like this. One second. What's not working? Tail -n. Yeah, perfect, right? So now the row here is 4, and if we go for wc-l, I'll cover this thing, wc-l with pipe and head underscore text, head underscore test Why it's not coming? Test.txt. Sorry, one second. So basically what I'm trying to do, I'm just trying to count the number of words in this file, you know. So it's WC. Okay. What's not coming? I need to check. But ideally what we check in industry, that the number of, and this is the interview question, you know, that okay, if you have a file, what type of file is coming into your system and how you are validating it. So the answer of this question is that okay, we have a header in the file and we have a trailer in the file. In the header, we have the kind of schema of the file. In the trailer, we have the control file, that is the date at which the file is generated and the number of records in that file. So if the number of records in the file match with the bottom row number of record, then we will say the file is valid. So these kind of things, you know. This is the most important thing. Ideally, you guys won't be using it, but if we want to change the mode of the file and change the owner of the file. So when I go for LSF&LTR here, right? So what you're gonna be seeing here, that there are, and I covered this thing in the first lecture, that if we have D in the beginning, this is directory. The first three is owner, then group, and then other. So when you see the read, write, execute, right? So the highlighted part, the first three bits are for the owner. Like if I talk about this Hive directory, then the owner has read, write, and execute both, right? And everyone has the read, write, execute for the Hive directory. But for the Hue, owner has read and write, but don't have the rights for the execution. The others has only read writes, right? But let's say if I want to change the mode, I won't be changing because it will corrupt my Hadoop environment. But let's say for this file, right? For this file, if I want to change the mode, right? So what I will doing, chmod 777. 777 means what? That I want to give all the permissions for everyone in the world. So I'll doing head underscore test.txt. Now if I do LSF&LTR again, so you will see here that this file is converted to green and everything is for all the people like owner, others, and the group, the permission has been changed. Okay, this is not the best permission to give, and ideally we should not give this permission. But yeah, this is just to show you guys. Okay. And one more thing which you're going to be using, and this is the question which you will be asked in lot of interviews. Let's say we have two servers, right? And we want to see the connectivity between two servers. So how are you going to be doing it? So the most easy command is to ping it. Like for example, let's say if I want to see the internet connectivity from my machine to their machine, because I'm working on the single system, I don't have the other machine. But let's see with google.com, right? So yeah, so what I can see that yeah, I have the connectivity from Google, and you know some bytes are coming in, right? So this is obviously people will asking you that okay, how will you test the connectivity and all? And let's say one more command is top. So if what top commands do, that it will tell you how many processes, how many top 20 processes are running at the system at this particular time. And this is a live command, so the running the result will be automatically refreshed, you know. So if I run it, one second. So see this. Yeah. So if you see this, it is automatically getting refreshed, right? So PID means process ID, user who is running it, right? So see Uzi, because this is HDP sandbox. So these all different processes are running at this point of time, right? These many commands. Manual is obviously, so for example, when I go for man means manual. So let's say if we want to test, if we want to say what tail commands do, right? So you will be doing like no manual for tail. Okay, I'm not sure why. Head, no manual for head. What's going on here? I'm not sure, but yeah, manual means so it's a manual to see the manual of the command, you know. Echo is a command in which echo is similar to print in the Python. or println in Java or something like this. So if you want to print anything, let's say if I want to print Nilendra, then it's something like this. Like if you want to type anything in, when I will be covering shell scripting in 2 minutes, I will be showing you echo will be used for the debugging as well. So let's say you are running 5 commands, and if your program is failing on the 3rd command, what ideally you will be doing in shell script, you will be putting echo after the 2nd, 3rd, 4th command and see, which echo is, running, right? Zip, unzip is obviously very simple commands. By zip, you will be doing the zip. By unzip, you will be unzipping the zip command. If you want to see, I can show you guys. So zip. Let's say if I want to, just 1 second, ls-ltr. So let's say if I want to zip, this file, right, hello.txt. Okay, so I will be writing zip, then the zip file name, let's say my zip.zip, whatever, and then hello.txt. So what you're going to be doing here now, when I say ls-ltr again, so you have a new zip file created here. You won't be using these commands a lot of the time, but people, if you say in an interview, somebody asks you that, okay, do you know Linux? Then people may ask some stupid questions, So these are those stupid questions. The host name is a very useful command. So host name is the host on which the system is running. So my host name is this, right? So host name right now it is giving the name of the host, but if you want to see the IP of the host, you will be writing -i here. So this is my local system, right? Okay, these are few commands which I need to cover. Any doubts about it here? So, because these commands will be very handy when you work for the shell scripting and all, Okay, so let's cover few things about shell script, right? So, okay, so one thing I need to ask you guys, what do you understand by shell script? Or what do you understand by shell, first of all? I won't showing you this. So what do you understand by shell? Quickly type the answer if anybody knows, like your understanding. Or you can unmute yourself and tell me. Any shell, not Python shell or script shell, whatever, like what do you understand? Okay, so see, whatever is written here, right, you guys can read it. Like this is an example for argument, my first name, last name, a place where you execute function in your perfect. But obviously you can execute your you can execute your function jobs even in ID, like integrated development environment. But what exactly the shell? So let's say, see this program what I written here, you guys can easily read it, right? But if I run this program, if I want to run this program on some machine, will my machine understand it? So shell is a program itself which will cover or which will convert your logic into binary, and it will send that binary language to the machine. So kind of it acts as a compiler and interpreter what you want to say. So for example, sometimes it can act as a compiler, and most of the time it's interpreter. So interpreter means it is interpreting each line at one time. So I'm writing one and it is giving me result. So it is interpreting one line at a time, right? But if I give it a script, it will even execute it. So it will compile it first, then execute it. So that is covered here, So for example, what I'm doing here, I'm putting my command on the shell, right? And what Linux shell is doing, converting my command to the binary language, and then sending this command to the kernel. Kernel is just the operating system for Linux system. So yesterday I told you guys, right? We have so many directories or so many folders in Linux system. One of the directories bin. So in bin, there are all the binaries of all these commands. For example, how system is understanding what hostname means. If I put hostname -i, how system is coming to know that, okay, if I give -i as a parameter, I need to give IP. If I don't give any parameter, I need to give the host name. This all the logic is written somewhere in the bin directory folder. Okay, but how this English language is converted to binary language, this black screen shell is doing it for us. Okay, as simple as that. And this is what I'm trying to convey here. that ls, date, time, whatever I'm doing, inputting in shell, it is converted to binary language, and then it's going to kernel, and we are getting result back in a human readable format. Okay. Now the question is, how many type of shell can be there? So majorly there are 3 types of shell. I will be using bash here, but there are bash means born. Again, we do not need to go into detail, but if somebody asks you how many types of shell are there, so there are majorly 3 types of shell: C shell, KSH, or Con shell, or bash. The majorly used shell is bash shell in the industry. Okay, and I will be pinging you this thing to everyone. Where's chat here? I'll ping you guys later. Even let me ping this here. So this is a very, very good tutorial what I found for shell scripting and all. So you guys can go through it after meeting. Okay. So let me go to the shell scripting now. So what we did in last 15 minutes, that we are running few commands, but if I ask you to run this command in one file, right? So what you guys need to do, you guys need to create a file and you guys need to execute it. So the file which we are creating to run all the shell commands or all the Linux command is called shell script, as simple as that, right? So I have created one shell script for you guys. Let me show you here. So what I'm doing here. So what I did here, that I created a simple shell script, right? So in the shell script, obviously shell script is a script which will execute all the commands, all the Linux commands for you in some sequence. Okay. So the first line in every shell script will tell you that which shell you need to use. And as I already told you, in most of the cases you're going to be using bash shell, but here it can be KSH, it can be CSH sometimes. And let me so that you won't get confused. If you find KSH here, then it can be Con shell. If you have CSS here, it can be Con shell, C shell. Okay, but I will be putting here bash. So right now I'm using bash shell, right? And I covered already that echo means if you want to print something. I will remove this line. This is duplicate. Okay, so what this line will be doing, it will just echo hello world, just print that, okay, my program is started, hello world. And if I write something like program is started, okay. And now when you use hash here, so hash is something what we use to comment something, okay. So this line won't be executed, okay. And now let's say if I want to give some parameters to the script, if I want to give some parameter to the script, the parameter will be, the first parameter will take as $1, the second parameter will take as $2. Okay. And if I want to find how many number of parameters we have given to the script, is it $hash. I'll show you guys, okay. So don't worry about it. In shell scripting, the variable assignment is very, very easy. So here what you're going to be doing, n is equal to 10. What this means that the shell will automatically understand that n is an integer, and this is what we call it, you know, dynamic allocation kind of thing. That it will automatically understand that, okay, 10 is an integer and it will convert n to int. Okay. And now let's say if we go for if and else, it's as simple as any other language and the most simple thing. So what if we want to compare something? So let's say I'll put some space here. So if I want to check if n is less than 10, lt means less than. LT means less than. GT, if I want to use greater than, we will be using GT. If I want to use equal, we will be going EQ. Okay, so I'll write it here for you guys. So GT and EQ. Okay, so EQ, right? So what this and what $n is doing here? So $n is just a reference to this n. Okay, and so what I'm comparing here, that if n is less than 10, then print this is 1-digit number, else this is 2-digit number. Okay, so obviously I'm just showing everything just for your reference, that how to make use of these variables and all, right. And now one more thing, let's say if I if I want to ask user something, then I will be using read. This is sometime, for example, when you, I'm not sure, whenever you log into some database, right, it is asking for your user ID password. So internally, if it is written in shell scripting, then read is used behind the scene. So here, if you see, read username and echo password, and when I execute, you will come to know, then read password. And what I'm doing here, and just for your sake, just for making it simple, that if $username means this username, right? If this username is equal to admin and $password is equal to secret, then echo valid user as invalid user. Okay. So, and again, this is if else statement. One more important thing is you can even execute executables. For example, if I want to create some directory, right? If I want to create some directory, we can create this directory inside using these what we call them, reverse codes. You remember the character below escape, this one, right? This character. Okay, so if you put something in these reverse characters, reverse codes, then it will execute it and it will create a new directory for you. Now let me show you how it is executed, right? So to execute it, we will just put simple this test underscore sh. No, sorry, test underscore sh. So what it is asking me, so see now, okay, 1 second, let me coming out of it. So see now, for this program, for this particular program, when I run it, I haven't given any parameter, right? And that's why my first name is coming as null, my surname is coming as null, and the number of parameter which I pass to this program is 0. But let's say if I give here Nilendra Singh, now what it's gonna be doing? My first name will be Nilendra, my surname will be Singh, and the total number of parameters should be 2, right? And now username, what we enter admin. Now it will, and this particular thing, right? This particular thing we use read command behind the scene. So when I put read here, when I put say this is echo in the script, and this admin will go into the username variable using read command, right? In the password, what I will be putting secret. So now ideally, now what next thing gonna be happening is the if else statement what I wrote in the shell script, right? And what it's gonna be doing, the username and password is correct. See, valid user, right? And now what the next thing is the reverse code thing, in which it will be executing something for us. Let's say if I want to create the directory from my shell, so it will create this directory from this, you know. And now if I do ls-ltr, so see there, so it created one directory for me, directory for my shell. Am I making sense, guys? So this is how in industry, see, nothing very fancy, right? It's very, very easy things, but these are the interview question what you're gonna be, but somebody gonna be asking you, right? But now shell script is just one thing, right? So in industry, why we use shell script is to make a wrapper. So let's say you want to ingest some data to HDFS, if you want to validate the data, you want to do the counting, you want to do some row validation, different kind of stuff. So what you're gonna be doing, you're gonna be writing different shell scripts for each program, and then you're gonna be creating a wrapper shell script, and you will be calling these shell script line by line, like one by one. So I try to mimic the situation like this. So I have created this test underscore run .sh, and what this script is doing, this script will be calling that test.run inside. So what I'm doing, so to run the script which I've just showed you, right, to execute it, if I want to call that script inside some other script, then we're gonna be using sh with test.sh. Okay, so let's say if I want to run test underscore run .sh, so it will do almost the same thing. Although I'm not running test.sh, I'm running test run.sh, but it is inside, it is running test.sh, right? So I'm using, and obviously I didn't pass any parameter, so it is calling 0, 0 everything. So let's say if I'm
can you
repeat
anything, like how did you run a like a script inside another.
Oh yeah, I'll go through. I'll go through it again. Okay, so I have put some any other character here, so that's why it's called invalid user, right? And let's say if I want to create some directory here, so directory from, I will come it again, okay, wrapper. So this is, now if I do ls-ltr, it will create directory from wrapper, right? Now let me cover that thing for you, that okay, how to run that, right? So this is the line, the second line. So I have a script test.sh, right? And I want to call that script from test run.sh. So what I'm gonna be doing, I will just put one line sh and the absolute absolute path of the script which I need to call. Okay, is it clear, guys?
Yeah, got it.
So this is, so let's say, and this is how industry works, you know. Let me show you one more thing. So let's say we have sh ingestion.sh, right? One script. The second script is sh validation.sh, and last script is validation row count validation.sh. So inside this script, these three scripts, right, all the Hadoop commands, all the scoop commands, all the Spark commands will be written, and in your scheduler you will be calling the main script, right? So there won't be a separate script for everything, there will be a wrapper around it. So this wrapper is written in shell script. Okay, so I will not be saving it. Just to exit out of it, we will be doing, I'm not sure you guys remember. So what we're gonna be doing, we'll put escape first, we will be putting colon, we will be going for Q, and since we do not need to save it, we will be putting exclamation sign to exit forcefully. Okay, so this is all about shell scripting, like very, very simple concept, nothing very fancy, but very important. Okay. So this is good. Shell scripting, any doubts before I move to HDFS commands now? Okay, so see, all the HDFS commands are behind the scene converted to Linux commands. Okay, so if you guys understood the Linux command or Unix command properly, then HDFS command will be a piece of cake for you. Okay, so let's say what we are doing here when I'm running LSF and LTR, right? So where this command is getting run on my local sandbox. I'm not in Hadoop right now. So let me explain in this way, right? So what Hadoop is, or what HDFS is just a software installed on your local machine. Okay, so when you run HDFS daemon or HDFS software onto your machine, what HDFS will be doing? HDFS will create its own file system over your local file system, right? So when I'm doing LSF and LTR, where this command will be executed on my local file system, it has nothing to do with HDFS. But let's say if I want to access HDFS file system, I need to write something like Hadoop FS. So what I'm telling now, that go to Hadoop file system and execute this command. See, it is taking time. Why it's taking time? Because it is going for HDFS. So now let me tell you one more thing. So whenever you are running any commands in HDFS, right, or in HDFS, there are two types of things. Either it will directly go for name node asking for the metadata and return you the metadata. So what exactly this command did according to you? What this command is doing, ls mean list, right? So what I'm telling HDFS that okay, please list all the file in your root directory. What I'm telling, please list all the directories in your root directory. So ideally, I'm client here. I run this command. What this command did, it went to name node. It went to it gave parameter the root directory and asked the name node, please give all the blocks location or the file names, which file name directory name which is part of the root directory. So this request went to the name node sees the data metadata and then return you everything. And when we run in local, see how quick it is, because obviously this is not going anywhere. The local, it's very fast, but when we run HDFS command, it is a bit slow because this whole cycle is taking place. Making sense, right? So most of the time, when you inquire something, it will go to the name node, it will inquire, it give you the result, and that's why the whole cycle is taking place. Sometimes it will go to data node as well. When it will go to data node, when you will create some directories. So let's say if I'm making some directory, right? Make directory. Okay. Sorry. I muted myself. 1 second. Just 1 second.
Okay. Now it's clear?
Now it's clear?
Okay. So
now it's clear, right?
Echo.
Yeah, there's
an echo. Why there's an echo now? 1 second. Yeah, now it's good, right?
Yeah.
Okay, perfect. So you guys get to know, right? The concept which I'm telling you in last 2-3 classes are somewhere everywhere interrelated, like how data node, name node interact with each other, where we will interact with name node, where we need to interact with data nodes. So this is where the whole concepts are coming in picture, So now I covered 2 commands here, ls and mkdir, right? And the same du, dus, let me cover quickly. So du means disk usage for whom? For us, right? For user. So disk usage for user, it will come later. And the most important command which everyone will be, see this thing, right? So disk usage for all the directives what I created. Am I making sense here? So it's very simple. And this is somebody asked me this thing long time back, that how will you check the disk usage? So what exactly happens, that, and this is not a user interview question, but it's an admin interview question. Let's say your data nodes or your system memory is full, and people ask you, okay, please check whether you have some unused file into some data nodes which are not getting used, in the user temp directory. Then you will be using at Hadoop fs -do. Okay. The most important command which I need to cover is copy from local or move from local. Okay. So copy from local is, see, I try to convey this thing, that this thing is local. All these files have nothing to do with HDFS. They are in my local sandbox. Am I making sense? They are, although everything looks black screen for you, but this is not Hadoop or HDFS. This is just a Unix system on which Hadoop is installed, right? If I want to go to Hadoop, I'm gonna be using Hadoop fs -ls. Then it will go to the Hadoop system. Let's say if I want to take this file, any file, right? Let's say my test.txt to Hadoop now. So first of all, let's see whether this file is there or not, right? It's taking time. Yeah. So if you see here, there is no my test.txt here. It is in my local system, but not in Hadoop system, right? So what I'm going to be doing, Hadoop -put, right? -put means put. See, we always talk in terms of local system. So put means put from local. Get means get to local. Okay. So we always talk in terms of the local system. So what I'm telling Hadoop, that okay, put this file to where? To my root directory. Root means just dot. Okay. Okay. -Hadoop fs. Okay. I missed the fs here. No command. Sorry. Hadoop fs. 1 second. Sorry, guys. Oh yeah, it's running actually. So it's taking time. Let me run it. Let me first try whether this copied or not. Yeah, so it's there now, right? So previously it was not there. So if you see here, there is no my test.txt here, but here now my test.txt has been copied, right? Now let's say if I want to copy this file, my first HDFS directory to local. Okay, so what I'm gonna be doing? I will say get and this directory, like obviously the first parameter in get and put is source, the last parameter is target. Okay, so this is my source and my target is temp and put enter. Okay, so if I say ls-l here, so my first HDFS directory has been copied here. Okay, so these are the most used command, like get and put, right? And whenever we are talking about get and put, we always talk in terms of the local system. Get means get to local, put means put from local, and there is other alternatives. If you guys don't remember get and put, more simplest form of them is copy from local and move, copy from local and move from local. Okay, both copy to local, right? Copy to local and copy from local, these two things. mkdir already covered. This thing, I haven't tried this thing, but let's try this thing. Okay, so let's say if I want to see whether any directory exists, so -test and then dot my first, what I'm trying to see here, that whether my first HDFS directory exists in my root directory in Hadoop. So I will be putting Hadoop fs -test and like this. Let's see. I haven't used it, but let's try. Okay, so what is telling you that you need to give 1 second. No test flag given. Okay, so I need to give some test flag, right? So the test flag is, let's say, -e. -test -e. Okay. Okay, so this directory exists, it means it runs successfully. Let's say if you put something like this, what it's gonna be doing? Let's say echo $? What echo $? will do? It will tell you the last command is successful or not. So it's 1. So it means it is not successful. One came, right? But let's say if I put the correct directory name and we will run echo $? then it should give something 0. Let's see. Yeah, see this. Am I making sense? So when I run for any wrong directory name, the echo $? give 1, but when we give the correct directory name, it will give 0. So it means this directory exists. Okay. This thing we already covered. These are very simple things. Change mode, change command, everything, right? One more thing is whether it's there or not. FSCK, it's not there, but let me cover that thing. So I explained in past 2 classes that everything in Hadoop is block, and the block is stored somewhere, right? But if we need to see where these blocks are and everything, so what we're gonna be doing, Hadoop -fs fsck dot fsck Hadoop fs Hadoop fs hyphen fsck. What is this? Hadoop fs. Why it's not working? Let me see, because this is important command. Let me just check for you guys. fsck in Hadoop. So Control F, fsck. Sorry, fsck. So what is doing? Hadoop HDFS Hadoop fsck. Okay, there's, you do not need to give this thing anything, you know. Okay, so Hadoop fsck and then path. Yeah, so this is what I was telling you, you know. So fsck means file system check. So fsck stands for file system check, right? So see, this is very, very important command. No, and it will be used a lot of the times in when you work in industry. So what it is telling you, that the first thing is where is your name node. So your name node is always on the port in industry on 50070. You run fsck command with this user and this password, okay? And then what is telling you, the status is healthy, okay? The total size is this, total directory is 5, total file is 4, and different kind of stuff. The blocks which are under replicated, total number of blocks and all. So it will tell you the overall, the file system image. So this is the most important thing, and people will ask this question. So keep this in mind, okay? So this is, you know, like Linux command and Hadoop commands are almost equivalent. Most of the time, all the Linux command will work with Hadoop, except change directory. So this is again a very tricky thing. You cannot change directory with Hadoop fs-cd. There's no command as change directory. You need to always give the absolute path if you want to change directory. Okay, this is again a very important thing. Now everything so yesterday we covered HDFS. Today we covered Linux system, shell scripting, and some HDFS commands. Okay, now I will be spending few minutes on MapReduce details. Although we covered MapReduce and we touched MapReduce in I think in the first lecture, but let's deep dive here. Okay.
Nilendra, I have a doubt. Like,
yeah,
when a file is already present in the HDFS, I like copy it to my local system, change it, and I'm trying to put it back in HDFS, but it's showing me an error, like the file already exists.
Yeah. So see, this is again, I'll cover this in detail, and this is a good question, right?
Okay.
So Hadoop, according to you guys, what is the main usage of Hadoop? So process some large data, right? And the MapReduce job, can you guys mute yourself, please? Thank you. Yeah. So why Hadoop was created? To process the large data. And the Hadoop jobs usually run for 10 hours, 12 hours, 24 hours, right? So what exactly, and for each Hadoop job, there is a file and directory created, right? So let's say you run one job in the morning and you came next morning and by mistake, you press the run button again. So what's going to happen? So if the file already exists, it will overwrite it in best scenario, right? But what Hadoop creators did, that okay, no. If file already exists, it won't overwrite it, especially with Hadoop commands. And this is a default functionality. So I'm not sure who asked this question, but it's a default functionality. Okay. And there is a reason behind it, the reason which I told you. But in Spark, this functionality has been updated. because Spark jobs are fast running jobs. Okay. Am I making sense? Okay. So I try to cover, people always try to cover MapReduce using word count program, but I want to make it more simple. So let's say we have different shapes here in different colors, right? So we have square, heart, circle, and star. So what I want to do, I want to count different shapes, number of different shapes in this file. Okay. So ideally, what we usually do that first we store the data to HDFS, right? So what I'm going to be doing, let's say this is my raw file. We'll be using a pen now. So let's say if this is my raw file, I will be storing this data to HDFS, and in HDFS, this data will be split into blocks. First block, second block, third block, fourth block, and each block in HDFS will be 128 MB in Hadoop 2 by default. You can change it to 64 MB or maybe whatever, but default is 128 MB. So this is the first step, right? The second step is you will be running some map job. I will be covering map job in Mapper and Reducer and a lot of detail in the next few minutes, but you will be running some map job and you will be assigning some integer to each of the block shapes. Like for example, let's say in this block, we have 2 round block, 2 square blocks. So what you are doing, 1, 1, 1 and everything, right? Then the last and the most expensive step is called shuffle and sort. So by shuffle and sort, what it is doing, right? So, and I will be covering this section later. So there is a partitioner here somewhere, which is deciding which shape will go to which new machine or which folder. So there is a partitioner sitting here, and I will be covering in 2 minutes. So what it do, it shuffle and sort. So in simple terms, what shuffle and sort means, transfer the output of mapper as an input to the reducer. As simple as that. And since we are moving data from one machine to another through network, this is the most expensive. This is the most expensive thing. Okay. And to prevent this, the only way is to do something onto this side, so that as less data as we can flow through the network, something performance tuning, something what I will be covering in 2 minutes, something can be done at this side, just to make sure that shuffling and sorting data should be small enough, right? So this is the input to the reducer. What reducer will be doing? It will be counting the sums. Now, since I covered that we need to do something, and I will be covering this portion, this partitioner portion where I'm drawing it. So the partitioner work like something like this. Okay, so and I will be covering input split in 2 minutes, but we went till here, right? I was talking about that map output will be go to shuffle and sort through some partitioner. So what partitioner is? So partitioner means to which reducer, which key will go to. So MapReduce always works as a key value pair. So by key value pair, I means that key. So in this thing, key will be this thing, like shape, and the value will be 1, right? So if you see here, every key, like all the squares or this, whatever the color is, the squares will go to this reducer. So who decided that this key will go to this reducer? That's the partitioner job. So when we go here, this is partitioner jobs to take the input, to take the output from map and to go to some particular reducer. See this thing. So this is what partitioner will be doing. Now the question arises, how partitioner will decide which reducer I need to send which key, right? So we can have multiple type of partitioner. For example, the default partitioner is hash partitioner. By hash partitioner, what is hashing means that divide, let's say in the hash partitioner, I will be saying I have 4 reducer in the system. So what this hash partitioner will be doing, it will divide each key. Let's say the 4 is my key. It will divide by 0. Sorry, it will divide by the number of partitioner If the result is 0, it will go to the first. If the remainder is 0, it will go to the first part, 0 partitioner. If something, let's say 5 divided by 4, the remainder is 1, it will go to the first partitioner, and in this way. Okay, so the most important thing when we decide the partitioner, that the partitioner should be consistent. The partitioner logic should be consistent. For example, if we pass 4, it will always give 0 here. It should not give 1.2. Like, we cannot use any non-deterministic partitioner. It should be deterministic. Okay, so that it will always go to the same reducer if we pass the same key. Am I making sense? Okay, now one more thing which I need to cover here, and related to the MapReduce itself. If you see here, this portion, it is not block. We are calling it input split. So exactly what input split is, and what is the relationship between block and input split. So in ideal world, there is 1-to-1 relationship between blocks and input split. When we talk about block are real physical files which are residing on HDFS file system. But when we are reading those files using some program, let's say MapReduce program, they will first convert to input splits, and then they will be passed to the our programs. Okay, so input split is nothing but the logical files. Okay, logical data files, we can say, or logical blocks. One more thing which I need to cover here as part of this particular thing, you know, right? We have let's say 4-node cluster, right? And let's say we have a 4-node cluster, something like this. This is name node. This is 1, 2, 3, 4 node, and we have this client sitting here, right? It wrote some Java program, MapReduce program. So what ideally we are doing, that we are sending this Java program to each of the node. This, and this. And then this Java program is executed on each of the data node, right? So in traditional world, in traditional databases, what we were doing, we were bringing data to our process. In Hadoop world, what we are doing, we are sending the process to the data. And that's where, again, the data locality comes in picture. So let's say we have 20 GB data here. We have 10 GB data here, and so on, right? And our Java program, this is my, let's say, Java program, right? This program is at max, what is the volume of this program? What is the size of this program? At maximum, 100 KB, at max, or maybe 200 KB. So ideally what we are sending this 100 KB to the 20 GB, to 10 GB, to whatever. And this is why the Hadoop programming is, Hadoop ecosystem or Hadoop world is fast, you know, because we are sending process to the data rather than sending data to the process. Okay. So this is, again, I think I missed this point, but yeah, I wanted to cover it here. Okay. So till now, I have covered partitioner. The partitioner is, the default one is hash partitioner, but we can go for range partitioner. Range partitioner means, let's say we have keys from A to Z, right? Keys from A to Z. And if I want to go for range partitioner, I can say A till E go to P1, F till K go to P2. So this is, I'm defining range. This can also be done. So this is the range partitioner. Some other partitioner can be there, I don't know, because in real-time world, nobody is using MapReduce as of now, and whenever people were using, they were using hash partitioning. Okay. So this is all about partitioning. Now, one thing which I was asking you guys here, that how do we prevent that less amount of data flows from here to here through the network? So right now, if you see that almost 1, 2, 3, 4, 6, 8 lines flowing from map to the shuffle phase, right? And then the counting we are doing at the reduce phase, right? But if something can be done onto this side, that okay, these two lines can be converted into this, that too, right? Some summation can be done locally on the map side rather than we give everything to reduce side. Can this be done? and if this can be done somehow, will it be beneficial? Obviously it will be beneficial, right? Because if we do some reduction onto the map side, then the data flow through the network or the shuffle and sort will be very efficient, and the less amount of data flows through the network. And that's where the combiner will come in picture. So if you see here, what we did, that the map data, map key value pair, we will put into combiner. The combiner will do exactly the same thing what reducer is doing onto the map side. Like reducer is somewhere here. This is our reducer. So the reducer will be coming like this, right? Or maybe different reducers. So what we are doing, let's say we are doing summation in reducer, then we are doing this summation logic. We will put this summation logic into the combiner here, So what is the benefit? That, okay, all the same keys, we will sum them in the combiner, and then we will send them to the shuffle and sort, to the partition and all. And that's where combiner will comes in picture. But one thing what we need to take care when we are talking about combiner, that I'm not sure, I don't remember the exact word. So for example, A plus B is equal to B plus A. What do we call it? Associative law, right? Something. So the logic of combiner should be associative. So summation and maximum, minimum are associative. For example, if I have 5 numbers, 4, 3, 2, or commuted, I'm not sure, but I'll tell you all the logic here. So we have 4 numbers, right? 4, 3, 2, 1. What is the sum of these 2 numbers? These 4 numbers. So 4 plus 3, 7 to 10, right? Let's say if I divide them into 2 parts, send one part here, and I will 4, 3, 7, and 2 plus 1, 3, still the sum is 10. So it means even though I divide this number into multiple partitions, the sum will always be 10, right? So we can use the summation logic on the combiner side. But if I ask you to average it, so what are you going to average? 1, 2, 3, 4, 4, 10 divided by 4. The average is 2.5. Averages. So what is that? How I counted the average? 4 plus 3 plus 2 plus 1 divided by 4 is equal to 10 divided by 4 is equal to 2.5. Now, if I send these two onto the one reducer, so what's gonna be the average? 4 plus 3 divided by 2, right? That is 7 by 2 is equal to 3.5. This is first output. The second output is 3.5. The second output is 2 plus 1 divided by 2. 3 divided by 2 is equal to 1.5, right? And then 3.5 plus 1.5 divided by 2 again. So 3 plus 1, 4. 3 plus 1 is, in this case it's coming same, but ideally we won't be using reducer like combiner with like average with combiner. Okay, so we can use min, max, sum, but average is not the right example to use here. Okay, so we have covered map, reduce. In between there can be combiner, there can be partitioner, and there will be shuffle and sort. So let's say if I conclude today's class, and I will be covering Java in tomorrow's class. So what are the different phases of map? So the first phase is mapper. The second phase I will be covering as shuffle and sort for sure. And the third phase will be reducer, right? But to make the program more efficient in programming world, what people are doing? Mapper, combiner, then here will be partitioner, then here will be shuffle and sort, and here will be reducer. These two things are optional. Okay? Till now, am I clear? Okay, so I think this is what I wanted to cover. Even I wanted to cover this mapper Java, reducer Java, but I think we are running out of the time. So I'll cover them in the first thing tomorrow. in today's class, do you guys have any doubt? Anyone?